Hi everybody. So welcome. This is going to be the last video where I'm going to finish the Connect 4 project. So there's three main things I'm going to be doing today. I'm going to be adding a black semi-transparent quad between the game over prompts and the board. That'll be very easy. That'll be the first thing I'm going to do. Then I'm going to modify the detection of the game over condition so that it will detect both diagonals, horizontal, as well as vertical. Right now, I just set it up so it would only detect a vertical win. After I'm done that, then I'm going to go and set up the code to drop the pieces. Now, of these three, adding the black quad is trivial. Setting up the detection of the win conditions is fairly easy. There's going to be a little bit of code, but it's not too tricky. The drop pieces is a little bit more work. Without that change though, your board doesn't really jump out. It's not as fun to play. So I recommend you do that, but I am going to make the drop pieces optional. So you definitely need to get adding the black quad and detecting the various win conditions. If you do though decide, you may skip. I will allow you to skip the drop pieces, and I will still check off as long as you've been using Git to do your version control, and I can see that you've been using branches and merging and doing your work. As long as you've done that, I will still check you off as having this complete. The drop pieces can be tricky, so you will have to decide if that's something you want to do. I definitely recommend you try getting that to work because you're going to see that it's a pretty cool feature to have. Okay, let's get started. Now, I have updated the assets. I've had to add transparency to them to basically get the dropping of the pieces to work, and I've added the black quad. So if you go to May 15th, I have a folder here. I'm going to download this, assets, and I've got my Connect 4 folder here, so I'm going to drag, actually hold on, just open up another prompt. Okay, so I'll drag that in here, and I will unzip it. Okay, that's not correct. What have I done? Okay, here we go. Replace these files. What am I doing? Okay, let me just fix this 1 sec. Okay, I'll delete that. Okay, there we go. So now we have these assets, and one of the things you'll notice is there's now transparency. So basically the space around the pieces is now transparent, and the spaces in the board are also transparent. And we have a black semi-transparent quad. So let's get started. We'll now start basically setting up our the transparent quad. So I'm going to go into brackets. Okay. All right, so let's just run this just to see where we left off, make sure everything looks good. I could also, of course, go in and run a git status command, and I should only see, okay, that is not what I'm looking for. Okay, let me open this again. Oh, wait, this is it. This is it right here. Okay, I'm gonna run this. Okay, so basically we can place pieces. Now you'll notice that the pieces are slightly offset now. That's because I've adjusted the assets. So we're gonna have to adjust their positioning slightly. It's very easy to do. Okay, there we go. So red wins. And as we can see, it's hard to sort of tell where the UI pops out because it blends in. So that's why we're gonna do the black quad. So in my assets folder, I have this black quad here. And you know what? I just realized I keep making this mistake. I forgot to switch my Git repo. Okay, let's do that. So I'm gonna go into my Git bash. Okay. Okay, so if I go git status, I have some untracked files, but I'm going to now check out a new branch, and basically I'm going to call this branch final polish. Okay. All right, so now I'm in this branch. I have these untracked files, which I'm going to modify, and then I will commit the changes. Okay, so first thing I need to do is I'm going to get this black quad. I'm going to create an image variable for it, and I'm going to initialize it. Now you'll notice I made the black quad the same size as the canvas, so it's gonna take up the entire size of the canvas. So that's 726 by 626. So up at the top here, create a new variable. So var black quad equals new image black quad dot source equals assets blackquad.png. All right, so we got that set up. So now we just need to render the black quad, and we can go into our draw function. So right here, we're rendering the board, then we come in, we render our pieces, and then if the game state is red wins or yellow wins, we render our UI pop-ups. So really all I need to do is render the black quad before I render the UI, and that'll place it in between the board, the pieces, and the UI. So here we go, ctx.drawImage, and we're gonna go with black quad, and the position is gonna be 0, 0. We're placing it at the top left of our canvas, and of course that means it'll move into the entire canvas. So I'll do that for red wins, and I'll do this as well for yellow wins. Okay, so let's try this out. Okay, that did not go well. Let's see, we probably have an error here, and we do. Okay, I have a typo. So it's draw image. Okay, let's try that again. Okay, there we go. So look at how much better that looks, right? So much better. Now, we could polish it more. Right now, the UI is displayed immediately after you place your piece. And it might be a little bit better to give maybe a second delay. We could use a timer, and then we could show the UI. But in this case, like, I'm just gonna move on. You can see though how much of an improvement that makes. And then of course we hit play again. Okay, so that brings us to another interesting point. Before, all of the assets were completely opaque. Now that they're transparent, when we render to start over, we're not actually rendering over some of the positions that were previously rendered. So we need to add in another call that's going to clear our board, our canvas. And let's do that right now. So as soon as I get my canvas, I'm going to say ctx.clearRect. This is going to clear the entire rectangle. And I'm going to start at 0, 0, the top left, and I'm going to clear all the way to the right, 726, and all the way to the bottom. Okay, there we go. So now, there we go, hit play again, boom, clears everything, and we can start over. Okay, so we're done now. We've already taken care of the first thing, the black quad. So next thing is detection of the game over. So let's take a look at that code. So basically I need to go to check win, and here's where we have check win. Now, we're only checking the vertical. So we need to also add in the horizontal and then both diagonals, okay? So the simplest way to do this would be to basically look at this algorithm, okay? Copy it, paste it additional 3 times, and then modify those 3 ones that we pasted to essentially basically use slight modifications to do those other diagonals and horizontals. That would be the simplest way. However, it's not really the best way because, let's see here, each of these is about 20 lines of code. So you're adding an additional 60 lines of code to your script. And if you look here, I mean, one way that I judge, how I'm doing in terms of my coding is this is only about, right now, we're at about 150 lines of code, 160 lines of code is all I have right now. And that's good because if I need to work on this or adjust it, having less code is a huge benefit. So definitely adding an additional 60 is not something I care to do. So basically we can what's called generalize this algorithm. We can set it up so it'll work with any diagonal or horizontal or vertical. And we can do that using a loop. So basically what I want to do is I'm going to create some variables that are going to represent how I'm going to move on the board to add up the pieces. Right now, if you look at the code here, what it does is it starts off at a specific row, and every time we loop, we basically move down or subtract one, which actually moves us up. So if we're at row 3, we go up to row 2, we check, is there a piece? Row 1, is there a piece? When we're done, when we don't find one or we go off the end of the board, then we stop and then we come to the next part. And here, what we do is we basically now reverse this and now we add to the row and we move down, okay? But the offset that we're using, we can use a variable to store that. Rather than hard coding in that we increment the row every time, we can use an array to basically indicate each time we move, what do we do with the column and what do we do with the row? And then in the second one, we can reverse that. Now this is a bit of a complex algorithm. I mean, we're using two-dimensional arrays again. I'm going to show this in a minute. So this might be a little bit confusing, but keep in mind, it's only a little bit of code. So as long as your project is working, you should have no trouble following what I'm going to do and basically getting it working fairly quickly because I'm only adding a few lines of code. So the first thing I'm going to do is I'm going to create an array here, a 2D array, and I'm going to call this offsets. Actually, I might as well, I'll create this inside the function. So let offsets equals new array. So this is going to be my array, and notice that the size is 4. That's because I have 4 positions, 4 strategies I need to use. I need to go vertical, horizontal, diagonal, diagonal. So that's why I have 4. Now each of these is going to contain an array. So offsets 0, this array is going to represent my vertical movement. So when I'm moving vertically, I use 0 for the horizontal, and I use 1 for the vertical. Okay, and I'll leave a little comment here, vertical. Now the next one, offsets 1, is going to be the opposite. It's going to be horizontal. So I'm going to move 1 position along the columns, and I'm going to not move along the rows. Okay, so those ones are pretty, I think, should be fairly easy. If you think about how I'm going to do this, I'm going to use this offset array. I'm going to loop through it, and then I'm going to check to see, based on the offsets, whether or not there's a piece beside the current position. Now, the next ones are the diagonals. They're a little bit more complex, but not that much more. So here we go. Offsets 2 equals, and the first offset I'm going to do is 1, 1. So that means as I'm checking, let's say I'm at a specific position on the board, and you could pick any position. Okay, so I've added in these offsets, and I want to now go over how the algorithm basically works. So for the offsets for vertical, I have a value of 0 for the column and a value of 1 for the row. You can see that right here. So this is how it would work. Let's say I place a piece on this position right here where my mouse is. All right. Now, after that, I'm going to then use that array. So the first position I'm going to move to has an offset of 0 columns and 1 row from this position. So I move down 1. And I keep going until I don't find a piece or I go off the end of the board. Then I go back to my original position. Now I'm going to reverse those offsets. So I'm still not moving. 0 is still the column, but instead of adding a row, okay, the second element in the array is 1, I subtract that. And now I move up and I keep going until I don't find a piece or I move off the end of the array. Now, the horizontal one is very similar. I'm not going to do that example, but let's look at the offsets for the diagonal. So the first diagonal has an offset of 1, 1. So 1 for the column and 1 for the row. So let's look at this. Let's say this was the piece I'm at right here where my mouse is. So as I move, I'm going to move one column, which moves me to the right 1, and then one column which moves me down, or one row, sorry, that moves me down 1 row. And I'm going to keep doing this until I either go off the board or I don't find a piece. Then I'm going to reverse that. So now instead of adding both a column and a row, I'm going to subtract a column and subtract a row. Okay? And that's how I'm going to count up, basically move to the positions where I need to check if there's a piece there. Now I also have another column though. There's just two diagonals. This one has a value for the column of -1 and a value of 1 for the row. So let's say I'm at this piece right here where my mouse is. Now, as I move, I would then move one column negative in the negative direction. So I'd subtract 1 from my column, and I would move 1 row down, which is here. And I would keep doing that. Then when I can't find a piece or I go off the end of the board, I would go back to my original position. Now I'm going to reverse those offsets. So now I add a column, and instead of adding a row, I subtract a row. So now I've made this column, this diagonal is what I'm checking. Okay, so I have all those set up, and now I can basically begin modifying my algorithm. So instead of having let row to check equal row only, I'm going to now have let column to check as well, because now I'm going to be moving between columns additionally. And I have a variable let count equals 1, and then I have basically these while loops that are going to move in both directions. Now the first one, instead of saying row to check minus minus, I'm now going to need to use my offsets. Now to do this properly, I need a for loop. So I'm going to loop through all 4 of my offsets. So for let I equals 0, I less than 4. Okay, so as I loop through, I'm going to pick one of these offsets based on the index of I. So row to check plus equals offsets I, and we know that the row is stored in the second index in that array. So this will give me the row index. And then column to check plus equal offsets I 0, because the column is stored in the first index in that array. All right, so now I have this condition here, if board column row to check equals player, so I need to change that to column to check. And I made a slight typo here, that should be a capital T. Okay, so column to check equals player, then count is incremented. All right, so that looks good. I feel like I've modified that. Now one slight problem we're gonna get to is I'm only checking right now if the row is greater than 0. The problem there is as I start moving diagonally and in different directions, I could easily, when I'm doing horizontal, I'll be going off the side of the board. So this check isn't going to be enough. So I'm actually going to have to check if I'm on the board. Now I'm going to use I'm basically going to make it while true, and I'm going to move to the next position. So I'm going to update my column and row, and then I'm going to have an if statement. I'm going to check if I'm not on the board. So if my index is less than 0 Or if the row or column is greater than the maximum size of the board, I'm going to then break out of this, break out of this while loop. So if row to check is less than 0, or column to check is less than 0, or, okay, so that's the idea that if I've moved to a position now at the top and I've gone to index -1, I don't want to keep checking. Now I'm going to say if row to check is less than 6, so there are 6 rows, but the maximum index is 5. Or if column to check is less than 7. Then I want to, wait, sorry. Okay, it's going to be row to check is greater than 5 and column to check is greater than 6. Okay, there I go. If that's true, then I want to break out of my while loop. That means I've gone off the end of the board. All right, then I keep going. I check, is the position I've moved to occupied by a piece that the player has? If it is, I increment my count. Otherwise, I exit the while loop. Then I come to this next setup here, this next while loop, and this is where I'm going to move in the opposite direction. So I can copy this pretty much. And this is where we could do, I mean, you could go even further and optimize this more by having this first while loop do everything. That would be possible, but it's probably not worth it in this situation. You're only saving a few lines of code, and I think the code would be a bit more complex. Okay, so now I keep going, and I need to now set row to check and column to check equal to, I need to reset them to the original position of the piece, because now we're going to check in the opposite direction. And now, instead of adding the offsets, I'm now going to subtract the offsets. And that's pretty much it. That's going to take care of the win conditions. And if I get to a count greater than 4, I'm going to say, I'm going to change the game state to game over. Okay, let's try this out and see if it works. Okay. Column to check is not defined. Line 101. 101. Okay, that's a capital C. Okay, column to check. That's good there. Let's see this one column, that's not right. Okay, let's try this now. So we fixed that typo. Okay, so it still works vertically. Let's try horizontally. Okay, there we go. So the horizontal one appears to work. Now this is just a quick test. We'd have to do more thorough testing to verify it, but it appears to work fairly well. Let's try a diagonal now. Okay, there we go. The diagonal works. And might as well, let's just do one more diagonal. Oh, darn it. Okay, let me try again. Okay, there we go. That diagonal works as well. Okay, so that's good. So we got that taken care of. So that's a big bonus now, and it's a fairly nice algorithm, right? It's not very long, it's efficient, and fairly easy to read. So I'm pretty happy with that result. Okay, so that means the last thing to tackle is dropping the pieces. And like I said, this is going to be tricky to do. So you have to decide if you wanna do it. Another thing to keep in mind too is the whole goal of this isn't necessarily to have the most polished, beautiful Connect 4 board on your GitHub initially. It's okay to have something that's kind of half done or you're in progress. So the idea though, hopefully you'll find a project during this course, maybe the Connect 4 board, or maybe the personal project you're gonna do, that's something that you'll work on outside of school, that you'll continue to improve and work on. And this code, after we're done working on it, there's lots of improvements, lots of new features we could add to the Connect 4 board to keep improving it. Okay, so let's see here. The drop pieces, basically I'm going to use, here's my overall strategy, how I'm gonna do this. I'm gonna create a new state. So right now we have playing, red wins, yellow wins, and draw. I'm gonna create a new state, which is gonna be called dropping a piece. So as soon as I click, instead of going and checking to see if you've won or not, I'm going to then immediately go into the dropping piece state. And during this state, I'm going to set up a timer that's then going to take up the top of the board, and it's going to also take the position where you're placing the piece. And it's going to use a timer, and every frame it's going to move the piece towards its end position. Once it gets there, it's going to cancel the timer, and it's going to place the piece on the board in that spot. Then it's going to call check win to see if you've won the game or not. So it doesn't sound that complex, but I am going to be jumping around, and I am going to have to change code in other areas. The nice thing about the detection of game over was that I only had to change the code in one place. Here I'm going to have to change it in quite a few. So if you are going to tackle this, you have to pay very close attention, because if you miss one of the steps I do, then you could be stuck and really not sure where the error is that you're having. Now, of course, I'll be available to help. So when you get stuck, send me your code. Just try to give me an idea where the issue is, and I'll look through it, and I should be able to help you out. Okay, so here we go. First thing I'm going to do is create a new state. So the new state is called dropping piece. Okay, we got that. All right. So next up, I want to create some more variables. Now, the variables I'm going to use, I'm going to create a start position and an end position array. And these arrays are going to have a size of 4, and they're going to contain, each of the 4 positions is going to contain something really specific. So let's look at that. So I have var start pos equals new array 4, and var end pos equals new array 4. Now I'm also going to create a timer variable. So var drop timer is now declared. Now for these positions, here's what the indexes are going to represent. Index 0 is going to be the horizontal pixel position of start of drop, okay? So that's gonna basically be the start of the board. When I've clicked, it's gonna be on that first row where the piece is then gonna start dropping in, okay? Index 1 is going to be the vertical pixel position of start of drop. 2 is going to be the horizontal or column, the position, the piece starts at. And 3 is going to be the vertical or row position the piece starts at. Now, let's just take a quick look at the board. So in other words, if I click anywhere, let's say I click anywhere in this column, the start position is going to be here, okay? I'm not gonna start it above the board. I mean, I could, but there's really no point. I'm gonna start it right here. So that means that in that array of 4 values, the first one is gonna be the horizontal position, and that's basically the pixel position where my mouse is. So remember, this is 626 pixels wide. So right there, that's, I mean, just guessing, that's about 400, around somewhere around 350 to 400, I'm guessing, in terms of the pixel position. The second index is going to be the vertical position in pixels. Well, that's going to be 0. Then the next one is going to be the column that I'm starting at, and that is easy to find. That's going to be 0, 1, 2, 3, 4. That's going to be the 4th column. Then the next one is going to be the vertical position. Well, that's going to be 0 in this case for the vertical row. So using that, I'm going to set those values, and I'm going to then, let's say that I have maybe a couple pieces already here. So that means that this is going to be the end position. I'm going to do the same thing there. I'm going to calculate the 2 horizontal vertical pixel positions, and I'm going to specify the end column and the end row. That way, every time I update the timer, it's going to move the position slightly. And eventually, it's going to get, I'm going to do an if statement to check to see if the piece has now reached its end position. And if it has, I am then going to set the board to have the correct piece based on the end position, column, and row. So it turns out I'm not actually going to use the start position, column, and row. But I'm going to add them anyway, just so that the information is consistent between the end position and the start position. So these are the same. These comments here, they apply to both the end position and the start position. Okay, so I got that. Now I'm going to go and add my function for dropping the piece. So I think that's the next thing to do. So right now, my get mouse position, this is going to go and it's going to, if we're playing the game, it is going to place the piece. Okay. So placing the piece is going to go, it's going to update the board, it's going to check for a win condition. Okay. And that's if we're playing. Otherwise, we're checking to see if they click the restart button. So I'm going to need to modify this, else if game state equals state dot draw or game state equals state dot red wins or game, okay, state dot yellow wins. Okay, there we go. Because I don't want it to check for that click if the piece is dropping, of course. All right, so I got that. So let's modify the place piece. So right now we're not going to, right here where it updates the board, we're not going to do that anymore. Instead, we're going to then enter into the, basically set up the function to drop the piece. And I'm also not going to check for the win yet because I want that animation to run where the piece drops. Okay, so let's create my new function. Okay, so I'm dropping the piece. And I need to know the column. And I need to know the row that I'm going to drop the piece into. Okay, so I have that information. So now I can pretty much initialize. The next step is going to be to initialize my values, my start pause and my end pause. So let's do that. So start pause equals, and the first position is going to be my horizontal pixel position. So to get the positions, I can look at my draw function because it's the other place that uses pixel positioning. So in my draw function, basically I'm getting the column times 100 times the player offsets. And then for row, I'm getting the row times 100 times the player offset. Okay, so the column is going to be 100 plus player offset. And I've got the row as the player offset. And the start position is going to be the column and the row. Okay, now I just realized something. I'm not going to do this in the drop piece. The drop piece is just going to animate. So I don't even need the column and the row. Instead, I'm going to do it up here. So if player is 1 and I've just placed the piece, then I'm going to say the start position equals, I've got the column times 100 plus the player 1 offset and then the row. That looks good. And my end position equals, okay, so sorry, that is, okay. So this is why, this one's a little trickier. The column is correct, but the row, remember, I'm just gonna start at row 0. So I can just go with player 1 offsets. And the start pause for row is gonna be 0. Now the end pause is gonna be very similar. So it's going to be the column times 100. Only now it's gonna be row times 100 plus player 1 offset. And the end column and end row. Okay, so that's all set up. Now I need to do the same as well for the other player. And the only thing I need to change is this is going to be player 2 offsets rather than player 1. Now it'd be really nice if I just fixed the assets so they were the same and I didn't need 2 arrays for that, but that's just how it is right now. Okay, so we got that. So now we're going to start our timer. So drop timer equals set interval drop piece. And I need to do this, I mean, if I do it every second, it's going to be really, really choppy. So I need it to be fairly fluid. So let's, in terms of milliseconds, if I want, let's see here, if I get my calculator out, if I have 1,000 milliseconds and I want that to go, let's say I want 30 frames a second. That means I need 33 milliseconds. So I'm gonna run this every 33 milliseconds. I'm trying to target 33 frames a second. Okay, so set interval, drop piece. Okay, and the other thing I need to do is I also need to say game state equals state dot dropping piece. And I can take this, the drop timer, and this, I can move this outside of the if else and place it right here. Okay. All right, so that looks pretty good. Now, inside the drop piece, this is where I'm going to have to, calculate the position of the piece as it drops. And that's actually not that hard to do. So I'm basically going to take my start pause and I'm going to increment the vertical pixel position. So that is the second element in the array or the index 1 element. I'm going to increase it by a fixed amount every frame, and that way the piece will move down the board. So all I need to do is go end pause 1 plus equals, I mean, we can tweak these values. Let's just say 50 pixels. So 50 pixels a frame is what it's going to move. That might be a little bit much. So let's just start with 30. Okay. Now I also need to detect if end, sorry, that's not end pause. It needs to be start pause. Okay. So if start pause 1 is greater than or equal to end pause 1, that means that I've reached my end goal. So now I am going to stop my timer. So clear interval, drop timer. I stop the timer, and now I actually want to place the piece on the board. So I'm going to then go, now I don't have column and row, so I'm gonna say end pause 3. That is gonna be the column position, and end pause 4 is the row position. So I place that on the board. Okay. All right, I've done that. Now the only issue is I need to get out of this dropping piece state because I'm done dropping the piece. So one way I can do that is I can call check win, and I can have check win either go to the game state or go to a game over state. Okay, and I'm gonna have to pass in once again the column and the row that I just placed the piece at. Okay, so that looks pretty good. Now let's take a look at our check win. So we come in here and we check to see if we won. We change the game state if we won, if the count is greater than 4. So basically I need to go else game state equals state dot playing. Okay. So I think I'm ready to test this. And the way I'll test it, I'm not actually going to see the piece drop yet. I'm going to do a console log. Okay, so every time that update is called, I should see dropping called in the console, and then it'll stop when it hits the position. So let's try this out. Okay, there we go. So we saw it dropping, it incremented, and then it stopped. And I'll drop another one. Good. Whoa, okay, that's bad. So that means it's dropping for a little bit too long. So why is that happening? Okay, so I see what the mistake was. I accidentally left a second drop timer here, so I'm creating the timer twice for the second player. So now this should work. Okay. Hold on. Let's save that. Okay, 12. Okay, there we go. So it's now dropping. I basically did a debug console log where I could see what the position was, so I could see where it should stop. So that is now working. Now, of course, I've somehow broken my drawing, so I need to now go and hook that in again. But that's really the last place now I need to do some work. I need to go into I need to hook up the drawing, and I need to now add a little bit new code in the draw function that'll draw the piece as it drops, because right now there's no code to do that. It only draws places on the board that have been placed. All right, so yeah, I go check win. Let's hook up the original draw now. So basically I'm going to still want to, when I place the piece on the board, I'm still going to want to draw the board. Okay, so I have the draw here. I don't see anything that would stop me from drawing the board. It clears the rect, and then it draws the image, and then it goes through and draws the board. Okay, I found had a little issue there. I'm using the wrong indexes, right? So the end pause, I want the third and fourth element in the array, but that's at index 2 and 3. And here it's going to be at index 2 and 3 again, and 2 and 3. All right, so now let's try this out. Oh, so I was debugging, so there we go. Okay, and you can see in the console, it's executing the dropping and then the piece appears. Dropping, piece appears. So now we're ready to go and we can hook in the code that's actually gonna draw that piece. So in my draw function here, I'm going to want to draw a piece. Now, because of the layering of the different assets using transparency, it turns out I'm gonna want to draw this piece before I draw the board. I want this piece to actually fit behind the board. So right after my clear rect, I'm gonna have some code. It's gonna say if game state equals state dot dropping piece. And here I'm gonna basically say now, so if player equals 1, else. Okay, so I'm gonna go ctx.draw image, player 1 image, and I'm gonna place this at start pause 0, start pause 1. So those are the pixel positions of the start pause, which I'm updating as I'm dropping the piece. And I'll copy that. And that's going to be player 2 image. Okay, so that looks pretty good. So let's try this now. Okay. What? Okay, so that did not quite work. Now it is drawing a piece, but it's not, the position's not being updated. So I'm doing something wrong here. Okay, let's look at the dropping function. I'm saying start pause 1 plus equals 30. Yeah, that should work. That should be moving the piece down. So let me see here. We're gonna console log it. Okay, I know why. It's drawing it properly, but it's not being called on the update. So inside my drop piece, I need to also draw it every time. So I'm not going to draw it. Right now I'm only drawing it when the piece is placed, but I need to call it. Okay, there I go. Boom. Okay, so that's pretty cool, eh? It's working, dropping those pieces in. Now because I changed the assets a bit, I need to change these offsets. So I'm gonna go now and modify those just so that I don't see any pixels in between the piece and the board. So I'm gonna change this to, let's say, 9 and 7. I made the pieces a little bit bigger as well, so I don't have to be quite as precise. 9 and 8, let's try. Still seeing a little bit there, so let's, okay, 9 and 7. Okay, that looks pretty good. All right, so a few more things. I probably just want to test this now and make sure that the game over states will work. Okay, there we go. I got a diagonal, I got the win, and I hit play again. All right, this is looking good, looking good. No. All right, I do have a game over message here, but yeah, something did not work there. Okay, let's just try, I'll just try it now vertical. Oh, okay, interesting. So my game over condition doesn't seem to be working for vertical. Yeah, it's saying game over, but then I'm not getting my prompts. That's strange. Okay, so I'll have to fix this. Okay, so I found the issue, and it turns out that when I'm doing my check win, when I find a win condition, I don't want to keep looping because it'll go to the next, say the horizontal or one of the diagonals, and you'll see that there isn't a win in one of those, and then it'll indicate that I didn't win. So I need to break out of this loop. That way I will exit the for loop and I will treat the win condition properly. So let's try this now. Okay, yellow wins. Okay, so I'm pretty sure this is now working correctly. Let's just do a few more tests. Yeah, there we go. Okay, the one thing though I haven't done yet, and this will be really quick to do, is I'm not detecting a draw. So I can do that really quickly. So basically, if game state equals state dot, sorry, I need two equal signs, playing, I want to check, I want to basically loop through the board and check to make sure that I haven't filled the entire board yet. So I'm just going to copy that code from the drawing function. It's going to loop through every piece on the board. Okay, and I'm going to set a flag. So let draw equal true. So it's going to say that it is a draw, and as soon as I find a piece that is not equal to the empty, or sorry, no, as soon as I find a piece that is empty, that was correct, then I'm going to say draw equals false. And then I'm going to say if draw game state equals state dot draw. Okay, and then in my draw function, I just need to make one small change here. So I'm going to add in my game over conditions, else if game state equals state dot draw. Okay, I draw the black quad, and I'm just going to draw the player play again. I'm not going to draw a player winning, obviously. And let's test this out really quick. Well, it's going to take a little while to test, especially now that I have the drop piece. Okay, so that, I mean, you guys test it. I'm not, it's just too painful to have me. I'm pretty sure it'll work. Of course, you always have to test this stuff out, but that it should certainly work correctly. So, all right. So I'm going to conclude things there. I think that this hopefully will give you guys an idea when you're looking towards your next project what you want to do. The Connect 4 project is, I mean, it's a medium difficulty project, right? You guys have now done the calculator, and you've seen me do this Connect 4 project. So you have some idea of a difficulty level. Interestingly, I'd like to ask you guys, which do you think would be harder for you to do? The Connect 4 or the calculator? I'm not even sure. I don't really know what the answer is to that. So I really would be interested to know what you guys think. If you guys could post that in the chat comments, I'd like to hear and see what you guys think, which would be more difficult. Okay, so I'm going to wrap this video up. D2L, you can pull down the assets and then finish up your Connect 4 board. Dropping of the pieces is optional, but I really encourage you guys to make a real attempt at that. Of course, I'll be around to help you guys finish that up. And that's going to be it. Enjoy your weekend, and I will have a new video for you guys next week.